Welcome to our Lesson 3.2 review video, and Lesson 3.2 was about reducing cancer risk. And before we get into the details of this, I want to make a shout out to Chad Shelley, the maker of this fine PowerPoint. In our very first activity, we learned about the risk factors when it comes to getting cancer. And there's four major risk factors, two of which you can see on this slide. The first one is biological. Basically, the older you get, you have a higher increase of cancer. But there's also certain pathogens that once you get an infection by these pathogens, that can increase your cancer risk. So think of the viruses that you learn about in 3.24, where the hepatitis virus can lead to liver cancer, HPV can lead to cervical cancer, and the Epstein-Barr can lead to other cancers such as lymphomas. All right? Now, another thing that works against, that you can help reduce your cancer risk is as you get older, there's certain tests and screens that you should get because an early detection of cancer can help give you a better chance of getting over the cancer. There's also a genetic factor. You can inherit genes that will lead to cancer. And we learned about these in activity 3.2.3 when we learned about the BRCA1, the BRCA2 genes. Those are your major breast cancer genes that will lead to basically the familial type. So if you remember the Cracking the Code NOAA video, we talked about those three sisters where one of them died from cancer, the other one carries the BRCA1 gene, and the other sister did not have it. All right. Now, this inherited cancer is also known as familial, runs in families, or hereditary, but most factors are not, or most cancers are not hereditary. Most of them are what we call sporadic. You just kind of get them due to bad luck. The other two major factors are environmental. There's just things in the environment that can cause cancer. We call these carcinogens. Carcinogens are basically mutagens, things that cause a mutation that will cause a mutation that leads to cancer. Pollution, many of the chemicals that are out in our our industrialized society will cause cancer. One of the most famous is asbestos. Okay, UV light or UV radiation can lead to skin cancer. That's what Project 3.2.2 was all about. And then just radiation in general. For example, X-rays, nuclear power plants, etc. All right. X-rays are the ones that you would be exposed to most during your lifetime. If you notice when you go to the dentist and they're getting an X-ray of your mouth, they cover your torso up with a lead blanket to keep the X-rays away from some of your major organs, so only just a little bit gets into your mouth. And you're only limited to get X amount of X-rays every year because they don't want to overdo it because that can lead to cancer. Your behavior can also do a lot to prevent you from getting cancer or basically increase your risk. For example, if you eat the typical American diet of a lot of red meat, that can increase your chances of, say, like a colorectal cancer or other kind of cancers. Smoking is probably the best way to get lung cancer. And also if you do smokeless tobacco, that can lead to mouth and throat cancer. And also, staying out of the sun and using sunscreen will also prevent you from getting skin cancer. So if you choose not to follow these behaviors, you can get cancer. When we were doing Project 3.2.2, when we were studying the effectiveness of sunscreens, we're really learning a little bit about skin cancer. And skin cancer comes in two main types. As you can see here, you got the basal squamous cancer, and this is the most common, but it's also the least dangerous, and you can find it anywhere in your body. So this is one that you can kind of get surgically removed pretty well, and you got a good prognosis. The other one is melanoma, and this one's most common on your face, chest, and legs, and it's also much more likely to metastasize. And so this is a very dangerous type of skin cancer. Now, one of the ways that you can kind of do a self-test or kind of check your own skin for skin cancer is to follow this ABCDE method of detecting skin cancer. And the A stands for asymmetry. So if you look over here on this graphic on the right, a normal mole it's got a symmetry. It's a perfect circle. And on the right, where you see the melanoma, you can see that it doesn't have a kind of an equator where it's equal on both sides. The border irregularity, a regular mole is going to have a nice circular shape to it, and as you can see over here on the melanoma one, it's got jagged edges. Color changes. If you see your mole changing from the normal dark brown blackish color to a red to a purple to a different shade of brown here, as you can see, that is also another sign that it is a skin cancer. If the diameter of the mole is greater than 1/4 of an inch, which is approximately 6 millimeters, that would be a sign that it is becoming cancerous and it's starting to grow. And then the one that you do not see here on this graphic is the evolving. In other words, if you see the shape of your mole change, or you see the color change, or you just see some changes in general, that would be a signal that this mole or this skin feature is becoming cancerous. Now, one of the ways that you can treat skin cancer would be through surgery, and I showed you this film in class where we showed a melanoma being removed from the guy's shoulder, and that could be done through cryosurgery and then the actual physical surgery where they cut out the stuff. But another way that you can use is a type of chemotherapy, and this is a 5-FU form of chemotherapy, and really what this is a pyrimidine antagonist. All right, pyrimidines are types of the nucleotide bases, for example, thymine, uracil, and cytosine. And the pyrimidine antagonist, like 5-FU, is going to prevent the enzyme that makes these pyrimidines from doing its job. So in other words, you're not making thymine, you're not making uracil, and you're not making cytosine. So it's going to be impossible for this cell to go through DNA replication. If you don't go through DNA replication, you cannot go through mitosis. In other words, you can't make more cells. So one of your features of cancer is abnormal cell growth. In other words, the mitosis rate or the mitotic rate is out of control. If you do not make these nucleotides, you can't do mitosis, and in effect, you're going to stop the growth of the cancer. Now, a pyrimidine antagonist like 5-FU will work on some patients, but there is also some nasty side effects. Surprise, it's a type of chemotherapy. All right, now, how can I use a molecular test to see if somebody has cancer? And this would refer back to activity 3.23. Now, in activity 3.23, you're dealing with Judy Smith again, that's Sue's mother, and Mike's mother, and she has cancer that runs in her family. Grandpa Bill had breast cancer, her mother had breast cancer, she has a sister with breast cancer, and so Judy and her sister Diana wanted to find out if they were going to have breast cancer. In other words, they wanted to see if they had the gene that would lead to that. All right? So we use marker analysis. Now, markers deal with a segment of DNA that's right in front of the gene, and they're therefore often passed on with the gene, so they're used as a way to determine or to look at if you have the special allele. Now, the markers are short tandem repeats. This is repetitive sequences of DNA. These are very highly variable in length, so therefore you're going to get different sizes of these fragments, and that's perfect for gel electrophoresis. Now, if you look down here in this graphic in the lower right-hand corner, the STRs, or the short tandem repeats, are in red, and as you can see, we have different numbers of these repeats and therefore different sizes of fragments, so it pretty much looks like perfect for gel electrophoresis. All right, now, how can I use these how can I use these genetic markers in electrophoresis to let me know if somebody has the cancer or not? Well, first of all, you're going to do a pedigree. So if you think back to activity 3.23, we had that pedigree in the middle of the activity, and it had marked in which individuals had the cancer. And so we looked at that pedigree, and we could tell, well, there's probably a gene that's being inherited from the generations to the generations. So then we took DNA samples from all those individuals involved, applied a restriction enzyme, then do our gel electrophoresis. So we noticed that Laura, Jennifer, and Judy all had the same marker. You remember that was that bottom fragment in their lanes. And we noticed that Diana did not have those same fragments in her electrophoresis lane. So if you looked at the pedigree, and then you looked at the story, and then you looked at the electrophoresis, you could determine that Laura, Jennifer, and Judy all had the gene that could lead to cancer, and Diana did not. All right. So if you think about the rest of activity 3.23, is that we were able to determine that Judy, Laura, and Jennifer had allele 3, which was the cancer allele, and then you had to write your letter to Judy explaining the prognosis and what she should do into the future. So let's go through this little checklist here. I can use a genetic marker to A, identify people with a gene for cancer, 2, conduct marker analysis on family members and unknown family members using gel electrophoresis. That also allows me to identify the STR sites using a standard curve. I can compare the STRs and identify the alleles possessed by each. Remember, that was allele 3 in this family. And then I can analyze the allele to see if there's a correlation between the alleles and the family members with the cancer. In other words, kind of back check it with our pedigree and our known people who have cancer. So this slide here basically sums up activity 323 in a nutshell. The genetic component or the familial part when it comes to breast cancer was the BRCA1 and the BRCA2 genes, both of which were tumor suppressor genes. And remember, tumor suppressor genes will basically reduce the rate of cell division. So when they're functional, they slow down cell division. When they are damaged, cell division is kicked up. Now, mutations in these will lead to tumors. 5 to 10% of all breast cancers are this familial type. And if you are a guy who gets breast cancer, normally you carry the BRCA2 gene. And in activity 323, that's what Bill had. Now, what are the preventative measures when it comes to breast cancer? Number one is you can do a prophylactic mastectomy. This will reduce the risk of breast cancer by about 90%. In other words, you're removing the breast before cancer shows up. Now, you may want to get this done if you test positive for either the BRCA1 or the BRCA2 gene. You have a history of calcium deposits in your breast, you've gone through some radiation therapy prior, or you've had breast cancer before. You can also do hormonal therapy because medicines or removal of the ovaries will be able to reduce the amount of estrogen because estrogen can help trigger this BRCA1 and BRCA2 genes. And always, good nutrition and proper physical activity, in other words, make you as healthy as possible, can also help prevent the cancers. All right, how can viruses lead to cancer? So this one comes from activity 3.24. Viruses can cause cancer because they will insert their DNA into a place that may turn on an oncogene, turn off a tumor suppressor, or it just may by itself cause a mutation. Now, here are some certain viruses that can lead to cancer. One is HPV, human papillomavirus. This one is strongly linked to cervical cancer. And recently, within the last 10 years, we've created the Gardasil vaccine, which is highly recommended for both males and females to get because that will help guard against some of the major strains of the HPV. But definitely, it's not all of them, but it's going to cover most of them. EPV, which stands for Epstein-Barr virus. This is one that can cause mono. This can lead to different types of lymphomas. The two hepatitis strains, hepatitis B, which we do have a vaccine for, hepatitis C, which we do not have a vaccine for, but both of those could trigger or lead to liver cancer. All right, so what is the importance of routine cancer screenings? And then you learned about this in activity 3.2.5. You should get routine screenings and at certain age groups, these kick in: prostate cancer, colon, cervical, breast, and skin, testicular, and lung cancer. If you have a certain risk factors, or B, you're at a certain age for those. All right. So as you were going through the routine screenings, you made a note in your lab journal of when all of these should occur. Now, as always with all cancers, early detection is key. Earlier detection leads to faster treatment, and hopefully you've gotten to the cancer before it has metastasized. Okay. Always, always easier to treat cancer earlier than later. All right. That's going to end this this review video. Make sure you take a look at the notes. Also, there are various PowerPoints that we have on My Big Campus. Make sure you look at those and pay attention to everything that's listed in your study guide. So, good luck on your quiz, and until next time, we're going to catch you on the flip side.